Hello grade 7s, welcome to today's video lesson. I hope you all are well. Before we start, I'd just like to commend all of you for working during the lockdown. It's not easy to self-study, it requires self-discipline, and it's something that would be expected more of varsity kids. So school kids need a school and a classroom, so well done for trying and acting beyond your years. In today's lesson, we'll be talking about methods of physical separation. You'll find this on page 82 of the textbook. So just to recap, methods of physical separation can only be used to separate mixtures. And if you recall, a mixture is when we take two pure substances, we mix them together, but they don't interact chemically. So for example, we could think of beans and rice. We mix them together, but the rice doesn't interact chemically with the beans. So the rice stays as rice, and the beans stay as beans. Now this mixture can be separated physically. For example, by hand sorting, you could pick out the larger beans, or maybe you could try using a sieve to separate the larger beans from the smaller rice grains. As a counterpoint to this, when in a mixture the individual elements interact chemically, then it cannot be separated physically. So for example, if we think of a cake, we have the ingredients, flour, eggs, sugar, milk. We mix them together, and once we put it in the oven, these ingredients interact chemically. And in the final product, the cake, we can't separate it back physically into the eggs, flour, sugar, milk. So let's go over the methods of physical separation. So this list is in the same order as that in the textbook. 1. Hand sorting. 2. Sieving. 3. Filtration. 4. Using a magnet to separate mixtures. 5. Evaporation. And 6. Distillation. 7. Chromatography. So let's start with hand sorting. So here I have a mixture of sand and paper clips. The sand hasn't interacted chemically with the paper clips, so I can now individually just pick out the paper clips. That's hand sorting. Sieving. So here's a sieve, and if I don't want to get my hands dirty, I can just pour this mixture in, and the larger paper clips will stay at the top, and the smaller sand particles will fall out the bottom. Next we have filtration. Filtration is used when we separate a mixture of a liquid and a solid. So specifically this is sand and water. So once I pour it in through the filter paper like this, the water seeps out the bottom, and the solid particles, the sand and small rocks, stays behind. Next we have using a magnet to separate mixtures. So once again, with the sand and paper clips, I can easily get all the paper clips using the magnets. Okay, next we have evaporation. So if you recall from the previous video, here I've mixed together salt and water. Now, even though the salt dissolves in the water and disappears, it hasn't interacted chemically. So they maintain the individual physical properties, and all we get is salty water. Now, how do we separate this once the salt has dissolved? Well, because water has a lower boiling point than salt, obviously. So if we heat this mixture, the water will evaporate and the salt will be left behind. So I've done that here, and you can see that all the salt has accumulated at the bottom of this Pyrex. So next we have distillation. So distillation applies to the gases. So what happens is a gas will evaporate from a mixture and it will touch a cold surface like a lid. And once the temperature lowers, the gas will change back to a liquid. That's called condensation. An example of this is if we heat the kettle. So steam will be produced, it will rise, and when it touches the cold lid, the temperature will lower and it will condense back into water droplets. Okay, lastly we have chromatography. Chromatography is when we separate a mixture of liquids. You can find an experiment of this on page 87 of the textbook. Let me get it quickly. Page 87. So here you are separating the pigments in ink using chromatography. And I've done that over here. So I have this dark green ink line that I've drawn on the paper. And what I did was I dipped this so that the bottom was just touching a little bit of methylated spirits. Now what happened was the methylated spirits rose through the paper. It's called capillary action. It's almost like a straw. And it rose, it passed through this green line and dissolved the pigments in the ink. So what happened here was the lighter pigments rose with the methylated spirits, and the heavier pigments stayed behind at the bottom. So in this case, the different pigments had different densities. So if you're struggling to understand the concept of density, you can think of water and oil. The oil would float to the top of the water because the oil is lighter or less dense than water. So in addition to what I've shown you here with chromatography, I'm going to send you the link for the video of the experiment. And you can just try and understand some of the concepts. You don't need to know the words like capillary action. You just have to understand the concepts. And once again, I'll also be sending some questions on the section which will add to the work that was sent out at the end of last term. And in these lessons, I'm just trying to show you some practical examples to go together with the theory in the textbook. And once again, if you're struggling to understand, please send me a message. And yeah, good luck guys. Have a good rest of the day. Thanks.